In applying integrals, we've studied area between two curves and cross-sectional volume. We've also done the average value theorem, right?
Right.
So we're going to add on a little bit to a lot of these are just pure math problems. Okay. So if we're going to take a function, there's another way to calculate volume or create a shape with volume. We've done cross sections where we added a shape vertically, right? Is anybody paying attention? Oh, we all are.
Yeah.
Montaigne.
Sure.
I forget to spell here. Okay. The other way to calculate a volume here is to rotate the shape around an axis, some kind, right? So we can create some figure, and what we end up with is a shape that looks like a fishy. That was not intentional, but there you go. Nemo shows up in class today.
Blame you.
There you go.
Beautiful.
Okay. What shape are we employing? It should be pretty obvious when we rotate around an axis.
Nemo.
A circle, right? So this is a circular shape. Keep that in mind. Circular. Let's spell this right. Circular. Okay.
What's the fun of spelling things right?
What's the fun in doing anything right?
Accuracy and precision. Having the truth of the universe at your fingertips. Ooh. I like it.
Now we're getting deep. Okay. All right. So, what we're basically doing is taking a circle area, right, and we're integrating it across a function. The key here is determining the radius. Okay. Just like with cross-sectional volume.
So is this like the reverse of cross-sectional volume?
No, it's just the different. So with cross-sectional volume, we choose different shapes. Okay, this is just a specific shape.
Okay.
Okay, so what's the radius? If I call this f of x, what's the radius of that circle?
Whatever f of x equals.
Yeah, it's just the height of the function, right?
Yeah.
Right, so in our case, we can directly substitute. And then if we want to have integral limits, okay, we just insert our function in the circle formula.
How close is one always like?
What if, okay, so that's a solid, this is called a disk. You'll hear people call it a disk, okay? Like a Frisbee disk because it's a solid circle. Okay. What if we have let's give Nemo a digestive tract.
Oh,
So we revolved around the x-axis there. What if we revolved the x-axis here, but only between the two curves?
That'd be top line bottom.
Right. The radius now becomes
f of x minus u of x.
Close.
Integral f of x minus u of x. Or,
Think we're revolving around the x-axis, right?
uh-huh.
So it's just
So- And we want these two shapes to be revolved. So let's draw it. This one, right?
So f of x plus u of x
And then
then?
this one.
It'll still be subtracted.
You have to subtract the area of the big. So if I was to calculate the area of this washer here, right?
Mm-hmm.
I would do the big area minus the little area, correct? Okay, same concept. Okay. We have to do the big area minus the little area. Okay. Okay, so it's area minus area, right? Some people consider this, so this function would be the outside function, right?
Mm-hmm.
And this would be the inside. So some people will write this as pi times the outer squared minus inner squared. That's another way people address that, outer minus inner. You can do top minus bottom usually works, bigger minus smaller. But just make sure you're thinking it through so that the circle areas get calculated properly. Good? Okay, let's do an example or three. Find the line B, obtained by revolving the region between y equals x squared plus 4 and y equals 2 about some qualifiers. X-axis 4. Okay. Okay. Okay, is this a disc or a washer?
Washer.
Yeah, it's a washer. Which one of these is top?
X squared plus 4.
Yeah. Because, you know, the y-intercepts give you kind of a clue there, right? So what we're looking at is taking that region and rotating it around the x-axis. So what are my integral limits? 1 to 3. What's the integral?
F of x squared.
squared minus 542 squared. I can just write that as 4 3
That's it. You can pull the pie out, right?
Oh, yes.
We can always write it that way if you want, doesn't matter. Foil. Let's do the fourth plus 8x squared plus 16 minus 4, if you want to make it quick. So there's your final volume calculation. Okay. You don't need to follow that one through, right? Okay. Good? All right, let's rotate one around a different axis.
Does this axis have an equation now?
Yes. It will. Okay, let's rotate y equals x squared plus 2. Around all it does is change your radius. Okay, that's all this does. So we're gonna, the region between those two curves, because they make a, no, it's more like football, because they have sharp corners.
What if you were to rotate it around an equation? So
4 minus x squared and x squared plus 2. So we're gonna take this region, right? Okay, and we're gonna rotate it around that. Y equals -3. So, going back to our other problems, the radius was the height of the function. This was 0, correct? Okay, how would I figure out the height of the function if that's no longer 0?
The integral of that top function in the y equals everything.
It's what?
The integral of that top function and y equals everything.
Right. So,
you have to do 2 integrals.
4 minus x squared minus -3 is your radius.
Yeah, we should.
So basically, you add 3 units to the radius. Correct. So before it was just a function, now we're adding 3 units to it. Right? Or subtract -3. The easy rule to remember is subtract always. Because if you subtract a negative, it adds it. But if it's up here, you subtract that value out because you're shortening the radius. Right? So always subtract. It's top minus bottom, just like area under a curve. Right? So this is top minus bottom. And then we're also going to subtract x squared plus 2 minus -3 squared dx. Right. So again, outer radius minus inner radius, you just have to figure out what that radius is. Okay. Oh, what are A and B? How would you figure these out?
Intersection is the 2 graph.
Yeah, those would be,
The two functions.
you wanna do a Y rotation?
Oh, what?
A rotation around the Y-axis?
Yeah.
Inverse it,
What?
not inverse it, but plugging Y.
Yeah, put everything in terms of Y. Same concept, right minus left, turn it.
Would it be in terms of X?
If they're rotating around the Y, it's in terms of Y.
It would be put in terms of X. No. Putting it in terms of X is this.
So Y equals.
When I say put in terms of
Yeah.
Y, it means this is a Y value. Right, okay. Let's rotate, find the volume. Of the solid, obtain. Oh, right, this that's a pain in the butt. By rotating.
By a math teacher, that's what she said. I should do guided notes for these, huh? Under. Y equals 9 minus X squared. 403. About X equals -2.
My last year's notes were like a bunch of definitions and then the example, and this year's notes are just the examples.
It's the same.
I give myself little hints, like crap that he says, like, woo-hoo.
Yeah, I just heard you.
So usually happens when I know, but it's
No.
There wasn't anything about the legit.
Okay, so keep, look at that,
Exactly.
right there.
Right, yeah. me
That's
too.
a Y axis, or sorry, vertical rotation.
Oh, I my brain just glossed over that.
Yeah, you gotta pay
Well, so you're
attention.
gonna do it in
Okay.
terms of Y.
I know, but
So-
still.
Give me a sec.
There's X equals -2, right?
Alright.
Now, build this up, 0 to 3 on the X axis. My point's at 0, 9, right? And at 3, 0, so my shape looks like that. Correct?
Yeah.
So under this. All right,
Wait, wouldn't it go all the way to the X equals -2 though? The shape?
no, that's your rotation axis. Your boundaries for the function.
Oh, I
Or
see,
zero,
I see,
zero.
I see.
Right, okay.
So the integral.
We are, so when we're doing vertical integration, we do right minus left, correct?
Yeah.
Okay, so we need
0 to 3.
no.
No?
Everything's vertical now.
0 to 9.
0 to 9. Okay, 0 to 9. Right? And it's right minus left. So what's the radius of the outer function?
Negative, or root negative y plus 9 minus -2. It's that function minus -2.
Oh,
So you gotta put it in terms of,
yeah, we have
Why?
to change it.
Yeah.
so it's root negative y plus 9.
Yeah.
Okay, weird brain just hit.
Oh, don't trust me, that's
Go, Is that right?
Yes.
Yeah,
Mhm.
and that's where we it.
Negative y plus 9. Wait a second. Why do you distribute that negative? Does it matter?
I don't care. It's easier when you integrate it. But you
Does it
just
do
type it
it
into the
for
calculator.
No, on the
Doesn't
outside
matter.
it's just -1.
Oh, it was a negative x, so you divided by the negative one, okay.
So, it's the function
Oh, you're right.
minus -2, so +2 squared.
Minus
And then what's the
Negative 2.
-2.
Or it'd be, no, it'd be 0 minus
0
negative
minus?
2? Is that positive 2 at that point, or is that negative
It's positive. Because that's a positive value, right?
Mhm.
Size?
2? There
Yeah,
it
it's positive too. Yeah, I'll put it here. Dips. Keep your ducks in a row. Hey, I just made that up. That's cool. I think I'm cool. Okay. Welcome to my party.
Look at you showing your children grow up. It's just no joke to you.
I've been around teenagers.
I was gonna
a
say,
lot
I'd
more
imagine
than
he
you guys.
knows that.
Besides the fact that I was one,
He's also been teaching.
I've been
them.
teaching in high schools for 14 years.
Gross.
Yeah, I get to that point at least once a year.
Walking.
Okay, so you good with that?
Yes.
And then if you're asked to do that on a calculator, just put it in with X's. You don't have to do anything, just put it in with X's, same answer. Right.
Wait, no, you still have to change it, but you just.
You just put an X here.
X as your variable.
Right there. Boom.
Yeah, okay.
Yeah, good clarification.
So how do you do, like x equals -2 in the calculator? What would be that equation?
You don't worry about it, because all it does, if you put that in as X's, it just rotates.
Oh, yeah, okay.
Right.
Oh, homework, yeah. Close my notebook.
Oh, so much effort to open it.
It is.
If that is hard for you to do, you're going to fail.
The homework or opening your
No,
notebook?
opening is notebook.
I'm not gonna get the
Oh, it's
generation
the
talk.
third or the fourth?
It's the fourth.
Today's the 4th.
Yesterday was my birthday.
No, but you forgot
Oh.
about getting the generations talk.
You turned 6?
18.
Awesome.
Taylor's class.
Oh, you're a legal adult now.
Ah.
Except you're still in school.
Yep.
High school anyways.
So it means nothing.
Okay. Well, congratulations.
I mean, I can legally buy scratchers and tobacco products now, so.